All right, here we are with some back-to-back meetings. So that everyone's aware, there's a button on the upper right of your screen for Q&A. If you click on that, you'll be able to ask some questions, and we'll be getting to those questions towards the end of the session. I'd like to introduce, very happy to introduce that Matthew Whelan is here to speak with us today. He's an economic analyst in Transportation Economic and Analysis Directorate at Transport Canada. His role supports policy development and decision-making through the application of transportation and economic data and innovative tools. He works with a team that specializes in performance and capacity analysis of multimodal transportation systems with a specific focus on container and grain supply chains. Over the past 5 years, he's been working closely with Canadian port authorities and supply chain stakeholders to support the development of innovative tools and data platforms. His master's degree in engineering at Carleton with a specialization in transportation, and he's here in Ottawa. And he's going to be talking to us about fostering digital tools at Transport Canada to support supply chain planning and growth. Over to you, Matthew. Thank you.
Thank you so much for that introduction, and thank you for having me. I'm very excited to be here to present some of the work that Transport Canada is doing internally on the digital transformation, especially when it comes to supporting supply chain growth, as well as the work we're doing with our many stakeholders. Just a short outline on the presentation today. So I'm going to touch on some of the Canadian context and our government's role in supply chain planning, as well as some of how we use data analytics to foster collaboration and decision making on transportation. I want to provide some kind of early examples that we've undertaken of evidence-based digital tools at TC, and then how these have led into some of these bigger case studies or visibility platforms, with the big one being the Port of Vancouver supply chain visibility project. And then I'll wrap up with some key considerations that we've learned through our work internally, as well as the work with Port of Vancouver. So supply chains, first off, I'll just say, like, the group I work with, Transportation Economic Analysis, our role is really analysis and research on transportation supply chains, as well as passenger supply chains. So we have a lot of background working with marine, port, rail, air, and surface modes, and specifically supply chains, key ones being containers and grain, but other very integrated supply chains as well. So we see that supply chains are the backbone of international trade, and we're definitely seeing that disruption risks are on a rise. Transport Canada's role consists of preventing the foreseeable and mitigating the unforeseeable in order to accelerate recovery and minimize these long-term consequences we're seeing from these disruptions. We're definitely seeing increased globalization of supply chains and a shift towards real-time supply chains. It's largely a private sector operating under market-based rules. With respect to digitalization, data visibility, this often leads to data governance challenges due to commercial sensitive information. And we're also seeing that these real-time supply chains result in, when there is a disruption, this results in very complicated and backlogged challenges. So Canada's ability to compete in the global market and prosper in the long term requires a solid evidence base to understand implications of key economic, demographic, and technological drivers on the transportation sector. Supply chain performance is an important competitive differentiator. It really captures how a country is able to move goods, and it's a key driver of growth and international competitiveness, helping to expand trade and attractive investments. We're seeing global freight and logistics sector is going to be transformed by digitalization in the coming years, and it currently is very much being transformed as we speak. The technology adoption could help create new value in supply chains, such as appropriate and timely adoption of technology within Canada's freight transportation sector can provide competitive advantages, and its potential for driving better decisions, increasing productivity, streamlining supply chains, intermodal processes, developing new data-driven business models, and harnessing economic and trade benefits. Transport Canada is quite advanced in using digital information and metadata to inform decision making. And I'm going to, following this slide, I'm going to present some examples of some of the work we've done to kind of build on that. But some of the strategic areas where step analysis can be used, and we use quite often, is to provide analysis of transportation systems to assist in the validation of multimodal infrastructure bottlenecks and potential areas where policy intervention may be required, to to provide strategic advice on system utilization, performance issues, and opportunities. This is often in support of policy development and infrastructure investment decisions. To provide visibility on key supply chain fluidity. I think a lot of this presentation will focus on this point specifically. To provide an ongoing process of risk monitoring to senior management on situations presenting risk to Canada's reputation as a provider of reliable supply chains. And this is something we've seen a lot over the last 2-3 years with the disruptions that COVID has had on supply chains, as well as some of the issues we've seen in Canada, specifically on flooding, fires in the West Coast and through BC and Alberta, as well as we've seen some labor challenges at the Port of Montreal. And these are really key areas that's stressing an already sort of stressed supply chain. And then, so you may ask what is required to support evidence-based analysis? TC is looking to become kind of an authoritative transportation data hub. We understand how crucial evidence-based analysis is to support these decision-making, and then we require significant contribution from our stakeholders, but we definitely have information gaps that we're trying to fill through projects, through collaboration, and through various initiatives. We continue to seek validation, engage with our stakeholders, so it's an ongoing process to ensure the data we're collecting is properly reviewing, properly analyzing the supply chain and is aligned with the priorities of other groups. And we do that through working through a number of forums for data cooperation and reporting on the performance and capacity of this system. So I'm going to run through a couple of examples of some digital tools that we've developed internally with support of our stakeholders over the last 5 to 10 years. These projects really look at how we've leveraged various forms of data, being a regulatory data, which is submitted to TC or to other government departments, data that we purchase through third-party agreements, or data that has been voluntarily shared with transport, but through our stakeholders, be it the port authorities, railways, or other transportation providers. And we're going to look at how this data is kind of how the projects were formed, as well as how they've led to some digital tools that we've used previously or ongoing to support decision-making and infrastructure investment. First project we're looking at is what we call gateway planning using CBSA data or the Canadian Border Security Agency. There was a challenge where we were seeing short lead times to plan terminal rail resources for inbound container volumes. So this is looking at the container supply chains. The objective was we wanted to relay advanced cargo information to key gateway operators, specifically the railways and the ports. So they had a better understanding of how many containers are coming in through the port, so a better container forecast. Expected benefits were to have this advanced planning and a better allocation of rail and marine terminal resources, and improve key performance metrics, including on-dock dwell time. TC, in this case, TC remains a custodian of raw data, and the ports and the stakeholders receive daily aggregated level reports to allocate their rail resources. This was not commercially sensitive data, and so it required sign off from ocean carriers, so in order to disseminate to relevant gateway stakeholders. So this was quite one of these processes where we required a lot of collaboration ahead of receiving the data in order to ensure that all parties were confident that the data was being properly held by Transport Canada and properly shared with the end users. So you can see it's there's a lot of stakeholders involved in this, starting with the Canadian Border Security Agency, who collects the raw data, Transport Canada, who receives the data and transforms it, the port authorities, who are the recipients of this clean data, and then their data consumers being the terminal operators and rail carriers. And Transport receives 2 data sets from this Pathfinder program we have related to what we call marine conveyance. Essentially, when all vessels arriving in Canada have to declare cargo to the Canadian Border Service Agency in order to have that cargo imported into Canada. So Transport Canada receives a cargo-based data set, which contains all the information on containers that were loaded in 24 hours prior to the ship's departure in Asia. So a good example, say, is Shanghai. When a vessel leaves Shanghai, 24 hours before that vessel leaves, it has to declare all its cargo to the CBSA. The second data set is a conveyance-based data set, which is voyage-related information, be it on the vessel, how many containers it's carrying, voyage number, identifying information. And this data set generally arrives 96 hours prior to ship arrival. So this was the original time frame for what ports were seeing. Was they were getting an understanding of how many containers were arriving at a 96 or 4-day outlook, which is not a long amount of time to plan rail allocation, like rail cars and locomotives and human resources. So the project was to produce an application that basically merged the two data sets and provided certain elements of these data sets to the port authorities to better plan their information. So here you can see that this table on the bottom of the page is kind of a snapshot of what the raw data would like. This is just kind of very small. The full database, I think, has 40 to 100 rows or 100 columns of data. So a big part of it was extracting so we have Transport Canada developed a processing engine that would extract the raw data, importing each container node into a Transport Canada structured database. The processing engine was continued to evolve to better kind of accept this data, and it contains complex algorithms to assign which containers and container elements are accessible to each data recipient based on business rules. So this is kind of the initial pilot project. This is the end result or the output from our processing. And essentially, Transport Canada had a pilot project with the port authorities and their data consumers to receive a codified, or Transport Canada codified the summarized forecasting model for the report and provided fields in the pilot that included the port, the vessel name, the voyage number, shipping line, container shipping line, terminal, and container size code and delivery location. These were originally manually produced raw data forecasts. So you see in these tables, there's a list of terminal names. These are in Vancouver, destinations in Canada, and the number of 20, 40, and larger than 40-foot containers. So these were provided to the ports on a daily basis through the pilot project to get a better understanding of how many containers were moving from, say, Vancouver in this case, to the various intermodal areas, key ones being Toronto, Montreal, Calgary, and then the US Midwest. Previously, the ports only had a few days view, and the goal of this project was to provide them with a much larger outlook, about 1 to 2 weeks. So the port authorities were basically monitoring the daily forecast and producing pivot tables to gauge these trends. And they're comparing the actual forecast to the actual arrivals upon ship arrival. So the observations that we're seeing in this project was that the view window into Canadian movement opened up to around 21 days prior to the ship, and these forecasts stabilized about 14 days out, with an increased accuracy around 7 days out. So there often are some reconciliation as the vessel voyage begins. Some containers may not have made it on the vessel, and so there's some reconciliation as the voyage continues. And so the pilot was quite successful. There was a lot of support from the stakeholders, specifically the ports and the terminal operators, as well as the railways. And so based on the results of this pilot, we developed a web-based data distribution system. So TC would work closely with the port authorities to architect a web service approach that the ports can subscribe to. And the benefits include the removal of the manual process on TC, dynamic querying of the web services to allow custom-based reporting within the ports, and weekend-based coverage, because previously it was a manual report, so it was a TC analyst who was producing these on a daily basis. And this is a project that is still very much ongoing, very critical to the port authorities planning their resources. We know that there's been a lot of work on the port side to develop end products that allow them to more easily share these reports with their stakeholders, being the terminal operators and the railways. And they also have been looking at ways to use the historical data to better predict future forecast trends, because one of the challenges still is that we have a 21-day forecast, or 21 to 14-day forecast, which allows for kind of that short-term planning. But the idea is can we better plan 6 months in advance or 12 months in advance? And I think there's some work ongoing at the ports looking at how this data can be used along with other data sets to kind of get a better understanding of what's coming, medium term down the road. So next I want to kind of talk about something we call in transport the fluidity concept. And it's a key project that I've been working on for the last 5 years, and it's been ongoing, as you can see, for quite a long time. And this will really lead into the bigger case study I'm going to talk about a bit, which is the supply chain feasibility project. So Transport Canada has been working on getting being able to better measure end-to-end supply chains, most critically the container and the grain supply chain. So the container being an import supply chain for Canada and the grain being an export supply chain. So starting in 2007, we were really looking at measuring performance on a single modal basis. And over time, we've been working on making that multimodal, so linking segments together, developing a key metric to report on these end-to-end segments, and then expanding into new trade corridors. And so the fluidity, what we call the fluidity indicator, it makes use of evidence-based information to assess and analyze the efficiency of supply chains in terms of reliability and variability in a North American context. It assists Transport Canada's work on strategic transportation systems, and also informs about pressures on transportation infrastructure. And this is really a horizontal project that we've been using to serve other Canadian government departments as well as our stakeholders. And it's very much a key reporting / dissemination tool that we use in our departmental reporting framework. We use it in internal performance dashboards. I'll touch a bit on how we've used it on a web-based platform as well as some of our public data hubs. So the first kind of component or a parallel project of that was developing some port utilization indicators, which these indicators were developed as a response to a policy challenge to provide evidence-based information and efficiency of Canadian supply chains, and to address common misconceptions or misperceptions about reliability of the Canadian system. So this is one of the projects that was probably the earliest project. It was launched in 2008 and was developed a set of utilization indicators at a national level to assist ports in monitoring operation performance over time. So this project, we followed a phased methodology to develop these indicators. It was through a voluntary approach with a collective selection and definition of metrics by several working groups. First was intermodal indicators was established. So it was first focusing on intermodal with 5 partner ports, Vancouver, Prince Rupert, Montreal, Halifax, and St. John. And then the next phase was the bulk indicators, which covered 8 commodities for 11 ports. So these intermodal indicators were the first ones developed, provided insights on the performance of various segments of port operations, including dockside, on dock, and at the gates, while the bulk indicators provide similar insights, including vessel turnaround time and number of vessel calls and throughput. And again, this is somewhere where we're seeing the voluntary approach and the close work of Transport Canada with its stakeholders to ensure that these projects were well defined, that they were aligned with the mandates of different groups, and that they were providing solid information. From there, so that was very much that unimodal or that singular kind of segment of the supply chain. We move into the fluidity concept on an end-to-end supply chain. And so I'm going to run through the inbound container supply chain. We also have a similar process for the grain segment. Some of my colleagues who work much more closely on grain could discuss this more. I'm work more closely on the import container supply chain. So the goal here was to provide is basically as much insight into supply chain segments as possible, and then capture these interaction between segments at key locations. And those segments where you have those interactions, such as the port, are the areas where we often see the most variability in performance, just because you have so many key stakeholders or key modes of transportation meeting in one spot. And in this process, we wanted to ensure that we were collecting high frequency data from different sources and systems. We wanted to manage the privacy and commercial sensitive information. We're dealing with, in some cases, very commercially sensitive data to the ports or to the railways. We want to ensure that there was multi-level access to trusted data information, and that there was a user-centric approach, so that relevant info and analytics were provided to the users to support their decision making. So it's going to walk through kind of the segments of how we measure this performance and where we're receiving this data and how we're using it how we're taking data, putting it into a single kind of system and getting this end-to-end metric. So just starting from the start of the supply chain, in our sense, we start with the marine segment. And so we're pulling components from various data sources, including our customs database, where we get information on the vessels, various AIS databases, so satellite tracking information, and that gets us an idea of what vessels are on their way to Canada or have arrived in Canada over the past 60 days. And then we take that and we will combine it. So the next segment is the port segment. So that's that key interface between modes. An important metric here is that port dwell, how long a container is resting at the dock at a port. Port dwell, that information, I spoke a few minutes ago on the port utilization indicators. That's where we're receiving most of our port dwell information from our stakeholders, which are the ports. And it's a very voluntary data point that they're providing with us. And we've worked closely with them to define, what the metric, what port dwell means, or how to measure it properly. And then the final major segment we see is the rail corridors or the rail transit. So in this case, we're receiving data from the railways. We're getting ramp data, so when a container is placed on a train and leaves a port region, and then when it's taken off a train at its destination market. So you can see key supply chains or key corridors that we focus on are the West Coast ports in Canada and the US, so Prince Rupert, Vancouver, Seattle, Tacoma, and Long Beach, as well as Montreal and Halifax in the east. And they're key inland destination markets in Canada and the US, mainly Toronto and Chicago. So we take these three segments of the intermodal supply chain, the marine, the port dwell, and the rail transit, and we get a final end-to-end measure. So you can see here is a main one we look at is Shanghai to the US West Coast to inland destinations of Toronto and Chicago. And from this metric now provides us with a better understanding of the competitiveness of the Canadian, as Canada as a gateway. We're really seeing how we're tracking the end-to-end transit times for Canada and for the US gateways, and we can compare the performance of these supply chains during normal times, or as well as during disruptive events. So you can see how events both in Canada and the US have affected the supply chains for both countries, and how Canada has, for the most part, continues to remain quite competitive with the US supply chains. And because we're able to measure this, we're able to use this for our policy decisions and our infrastructure investments to show the strength of the Canadian supply chains. One component that was part of the original part of that project was the web-based platform. So it was one thing to collect and build those metrics. It's another thing to then disseminate it to the stakeholders. So in the 2015s, the mid 2010s, we developed a web-based platform for these fluidity metrics and the POIs. And the dashboard was designed to basically ensure that data provided by each organization is secure and access is managed so that the competitiveness within the gateway is not impacted. And I think this is a theme that's carrying through a lot of this presentation, is ensuring that data is secure and access, and that everyone feels that everyone trusts that the data holder is working to ensure that their data is not provided to is only provided to the right people. And so essentially we had this application that allowed stakeholders to view the performance of the container supply chains for multiple segments and various corridors. It was designed to ensure that the data provided by each stakeholder is secure and access is managed so that the competitiveness within the gateway is not impacted. And it was a platform to transfer, compile, and display data. So the ports themselves were able to log into this platform, provide us with their data, specifically the port utilization indicators. We were able to take that, bring it into our systems, and in the case of the end-to-end fluidity metrics, use the dwell component to build this longer end-to-end supply chain. The platform is still very useful today for disseminating some of the data between stakeholders. And there was a period of time where we used it to disseminate this information to other government departments, as well as our other policy groups within transport. So a lot of this work, this early work on data, leveraging data visibility, and developing some data tools or digitization tools kind of led to the main kind of component of this presentation, which is the Port of Vancouver Supply Chain Visibility Project. And I just want to thank the Vancouver Fraser Port Authority for these slides. They were leading, they really led this project. Transport Canada was a supporter through the governance, through steering committees. We provided them support through funding support, as well as guidance. But a lot of this project really comes down to the work of the Port of Vancouver. The Port of Vancouver, we're seeing a lot of growth. A lot of growth in China is placing pressure on the Port of Vancouver as an import gateway to North America's import and export markets. There's physical constraints imposed by the geography of the area, such that there is really severe limitation to expansion, especially for railways, anchorages, terminals, and the port hinterland. The demand really emerged from infrastructure evaluations for near real-time data from the various stakeholders involved in capital expenditures. So the role for Transport Canada was as a stakeholder and facilitator to gather various stakeholders around a common goal. And Transport Canada invested $250,000 in the initial phase of the project to allow the Port of Vancouver to do a pilot project with key stakeholders aimed at improving the export of bulk commodities. In this case, it was focused on export of grain, coal, and potash, and a focus on the rail and marine transportation components. So this project was launched in 2018. So this was the initial pilot, occurred over about 2 to 2.5 years, wrapping up in about 2019, early 2020. Just kind of give a bit of context on the Port of Vancouver and the region itself. It's located on the southwest coast of British Columbia. Port of Vancouver extends from Roberts Bank and the Fraser River, and including the Burrard Inlet. Geographically, Port includes more than 16,000 acres of water and more than 1,500 acres of land and hundreds of kilometers of shoreline. It borders 16 municipalities and intersects the traditional territories and treaty lands of several Coast Salish First Nations. Port of Vancouver is about the same size as the next 5 largest Canadian ports combined. It's home to 29 major terminals and serviced by 3 Class 1 railways, including CP, CN, BNSF. The port is able to handle the most diversified range of cargo in North America, including dry bulk, containers, break bulk, liquid bulk, automotive, and cruise. It's also home to over 170 trading economies around the world, and it handles about 1 out of every $3 of Canada's trade in goods outside of North America. So the BC Lower Mainland has been facing challenges amid intensifying freight traffic. The Lower Mainland is very characterized by heavy rail and road traffic servicing the Port of Vancouver. We're seeing a large mix of commodities transit through this area, as the port is, as I said, it's the largest gateway between North America and international markets for Canada. There's many operational challenges exist in the Lower Mainland, in particular hard infrastructure challenges of multiple natural choke points. There's some challenges with bridges to the North Shore, at-grade road and rail crossings, and the geographic constraints in an urban area. And there's supply chain coordination challenges that impact operational decisions. This includes rail interswitching between the 3 major railways, as well as the short line, and coordination between 25 marine terminals and inland transportation modes. There was, as you can see, there was definitely a very clear message from stakeholders to the Port Authority, as well as to Transport Canada, This is the need for better data visibility in order to better plan, better make decisions, and in order to be more globally competitive. So the issue was there really was a lack of transparent information on sharing on performance of key strategic supply chains in the BC Lower Mainland. And an evidence base was needed to assess infrastructure requirements and better inform coordination and planning activities. The objectives of the supply chain. So like I said, Transport Canada invested $250,000 in 2018 to launch the supply chain visibility pilot. And the objective of this pilot was to demonstrate benefits of better end-to-end supply chain visibility, identify bottlenecks and improve planning of capacity and public-private investment in the region, create trust and collaboration across stakeholders by developing a platform for the secure collection, validation, and reporting of supply chain metrics for key commodities moved to the BC Lower Mainland. The focus on this first phase, I said, was on movements by rail for 3 key commodities, these being coal, potash, and grain. And we was collaborating with working group members to collect port terminal, and marine data, validate and analyze the data on an ongoing basis, and produce agreed upon performance measures. The outcomes of phase 1 were building a reporting tool with near real-time information on agreed upon performance metrics, customizing the tool to report performance metrics at 3 levels of detail, and giving participant stakeholders the ability to measure their performance against the industry average in the gateway. And you can see I think there was about nine marine terminals, 2 railways, and 1 labor representative participate in this. So we have a wide range of stakeholders, all with they all have a common goal, moving their goods through the Canadian Vancouver Gateway, as well as increasing trade for Canada. But they also all have their own very, important commercial interest in order to move their products. So it's a very challenging atmosphere to work in. The project, there was wide industry input into the pilot, and there was 2 levels of governance of the project. The project was overseen by a steering committee, and this was composed of Transport Canada, CN, CP, Port of Vancouver, and the Western Grain Elevator Alliance. And then the steering committee was supported by several working groups. And these were composed of technical experts from the participating organizations, including the railways, terminal operators, shippers, the port, Transport Canada, as well as Deloitte, who was the consultant working with the port and working with Transport Canada to develop the metrics, engage with the stakeholders, and develop the real-time dashboard. The scope of the feasibility project, the pilot was aimed to scope the feasibility of the project and initiate a dialogue with industry on the application of the results. KPIs were developed through these working group meetings and through extensive consultation with the industry. The indicators were developed to measure performance for specific segments or nodes across the system, with a specific focus on the railways for the pilot project. For example, performance is measured at shipping origin, such as a mine or a grain elevator, along the rail network, between origin and port. So, for example, a grain elevator in Saskatchewan and the port in Vancouver, or within the gateway, which is the Lower Mainland, and interchange between modes at the port, so between rail to terminal and terminal to marine. The KPIs were organized into 3 main categories: cycle time, efficiency, and throughput. As you see, data was organized into 3 levels of detail: the executive summary, an aggregate view, and a stakeholder view. And all participants will have their own unique access to a near real-time dashboard that provide reports on key metrics around cycle time, throughput, and efficiency. So the dashboard was designed to ensure that the data provided by each organization is secured and access is managed so that the competitiveness within the gateway is not impacted. Each organization had a different view of the data, with detailed access to their own data sets and aggregated view of other participants. Participants included the terminal operators, transload facilities, railways, shipping lines, trucking companies, cargo owners, industry associations, port authorities, as well as federal, provincial, and regional transportation authorities. As I said, the dashboard would have the ability to display the information at 3 levels. The aggregate level is really the gateway view, the industry level, which is a commodity view, and the firm level, which is the stakeholder view. Secure logging credentials would govern each stakeholder's access to information at each level. There was a 2-level authentication provided so that for security. And the value is for each stakeholder to be able to view their performance versus the industry and the gateway. And they can compare their performance versus the industry and versus the gateway. They were able to view their performance the next day, and they were able to filter by date range to view performance trends. So here's an example of a pilot dashboard, and this is the executive summary slide. You can see this provides kind of a gateway view and provides information on various components or various segments of the supply chain. Right here, we're seeing it aggregated across all of the commodities, but depending on your access, you were able to filter for a specific commodity, so be grain, coal, potash, specific terminals, and filter the date range, railway, and so on. So on the executive summary, which I think is really the page that provides probably the most information, the best snapshot of the performance of the gateway, we were able to see the incoming rail cars for each commodity, the rail cars in the gateway, vessel cycle time, rail cars gateway cycle time, and throughput. So some of the metrics that we really were looking at and seeing is total rail cars that during the issues we were seeing with the flooding and issues we were seeing with wildfires in BC, this metric really provided a good idea of how many rail cars were, say, stuck or were backlogged in central Canada and how we were on way, so we can get a better understanding of how many are incoming and or how many, or if it's really dropping. We're seeing challenges of getting rail cars to the origin points. Something such as the total railway cars in the gateway. You're seeing how many loaded cars in the gateway and how many unloaded cars in the gateway. This provides a better understanding of the balance. So if you're seeing a very unbalanced, it means that there's some challenges in getting cars to the terminals to get them unloaded and back out to their origin ports. So the metrics provided us a good understanding of the performance of various components of the segment, and it was really an early syndicator or early signal, to understand kind of pressures on the system. Here's another example of a dashboard page on the dashboard is the cycle time. Again, this one looks more closely at the rail segment of the supply chain, and it tracks a rail car's time spent at a cargo origin, on its rail journey, or at the marine terminal. And also you can use this to track a vessel's time spent at port or at dock. So participation in the supply chain visibility program benefited the industry in Canada and provided a collaborative space to optimize supply chains and boost economic growth. The data in this format, it was very valuable. We saw it as very valuable to identify bottlenecks and choke points. It was able to inform operational changes, and it informs infrastructure investments. However, transformation doesn't come without its challenges, including achieving full industry participation, including understanding the value of project outcomes and support from existing industry and government partners. And another challenge was establishing data governance and selecting the right digital platform that ensures the data is securely stored and responsibly shared. So these are two very important challenges that were addressed through the project and continue to be addressed as this project moves forward. So based on the success of the pilot, the Vancouver Fraser Port Authority and the Prince Rupert Port Authority applied for and received federal funding commitments from the National Trade Corridor Fund to develop the West Coast Supply Chain Visibility Program. So in 2019, the ports received this funding to take this pilot phase that was developed by the Port of Vancouver and move it into a more full-fledged program. So with the support of this funding, the program partners are developing a program that will report on all commodities, additional modes of transport, and as well as import cargo. So mainly the container side of the container market. The objective of this program is to create a digital backbone to support enhanced collaboration and optimization of Western Canadian supply chains, develop an insight-driven gateway. This will enable a smarter evidence-based approach to decision-making and translating into action. The program would provide enhanced analytics and forecasting capabilities, including the ability to monitor supply chain performance across all commodities through a near real-time digital dashboard. So that's similar to the dashboard I showed you previously, but expanded to include more commodities as well as more transportation modes and more tools. Predict terminal-specific arrival of rail cars to better identify operational constraints and capacity bottlenecks, and to improve import and export cargo forecasting, support long-term operational planning. Obviously, there's a very complex and large group of stakeholders who have a role to play in moving goods through the supply chain, and each of these groups will benefit from the program through enhanced data, visibility of goods movement, and operational tools. Through engagement with industry and stakeholders, the port has heard and understand the importance of data security and data access to all gateway members. So this is something, I think, a theme that's really carrying through is the data governance component of these projects, as well as the trust that's built between the stakeholders in order to share and compile this data and ensure to use it in a way that supports Canada as a gateway, but it doesn't ensures that the commercial sensitivity is maintained for the stakeholders. So after a rigorous selection process, the Port of Vancouver selected Informatica's data management solution as a digital backbone of the West Coast supply chain program. Supported by Informatica's technology and expertise in data governance, the port is building out data management policies, auditability, clear roles, and process as part of the data governance approach. So this is something that's is ongoing now. The program launched in 2020, and there's been extensive stakeholder engagement over the last 1 to 2 years, as well as development of the platforms and tools, and working with Informatica to develop this data governance. So in terms of the governance, I think there's three kind of key components of this, and this is data security, data access, and data usage. In terms of data security, data would be hosted on premise at the Vancouver Fraser Port Authority offices, and only port authorities would have access to the raw data. There'd be an automated audit process weekly, and data would only be used to feed into KPIs for dashboards, and each user will have their own customized view, similar to the pilot project. All participants providing data will have a master data sharing agreement in place with the Port Authority. On data access, we want to ensure complete transparency. The port is establishing a formal data governance council made up of industry representatives that will provide strategic direction on the use of data. And this will provide input on data management processes and new analytical tools that are being developed. When it comes to data usage, all participants will have their own unique access to the dashboard that will provide reports and key metrics. And the dashboard will provide a customized view for each organization, along with a view of the overall industry. And the program is really intended to be a collaborative initiative with the primary goal of providing the tools to support the industry. Information derived from this may also use for future infrastructure investments. So the key here was essentially no finger pointing. This data would be used not to identify modes or players within the supply chain that are underperforming, but to understand how the gateway itself as a whole is performing and where to better apply policy decisions or needed infrastructure investments. So this is ongoing still, and the hope is that in the next year to two, we would have new metrics being reported to the supply chain visibility program, to the dashboard, and we have a dashboard that reports on reports on the grain, coal, and potash as before, but also the expanded commodities and expanded modes. As the pilot really focused on the rail mode, the program will look to ensure that all modes, including trucking, marine, and port, are more better represented, and it will cover kind of the full Western Canadian region. So wrapping up, just kind of some key considerations to touch on. definitely through these projects, we see the role, the federal role in establishing a government model are important. So having the federal and provincial governments playing a convener role and working with these stakeholders to establish this governance model. Ensure that you're convening diverse stakeholders to solve the problems and address the "what's it in it for me" question. This really includes proactive engagement to help collectively address regulatory and government changes, and ensuring that there's ongoing consultation. We want to build and obtain consensus early on key elements of the framework, such as identifying and agreeing on sources of data, adopting full transparency on methodology, and understanding the end-to-end supply chain performance. And we're really seeing that strategic infrastructure projects can have transformative effects, and supported by a merit-based approach and system-wide perspective, addressing immediate issues while building for the future, and leveraging investments to maximize scope and scale. Well, thank you so much for taking the time to listen to my presentation, and I'm happy to answer any questions.
Thank you very much, Matthew. What a fulsome presentation, a lot going on, and I learned a lot. I did not realize Port of Vancouver was so absolutely huge. Very impressive. I don't have any questions yet, so just a reminder to everybody, you can ask some questions there. I have some for you though.
Okay.
So we've applied this to the West Coast, or specifically Port of Vancouver. Has there been any sort of interest in sort of applying the same sort of model and analysis, say, around ports, Montreal, Toronto, Halifax?
Yeah. So we definitely we've engaged with ports across the country and different modes across country on like scoping out visibility projects or even components of visibility. A good example, at the Port of Montreal, we've worked with the port to better understand their truck gate metrics and their truck visibility. So the Port of Vancouver is a very rail-based port, whereas Port of Montreal is more of a trucking-based port in terms of a lot of the goods are moved by truck. And so challenges we were seeing were long gate wait times, and long queuing, and impact. Those were impacting like truck waiting outside the gates were impacting local communities. And so a lot of the work at Port of Montreal was at better understanding how long trucks were queuing, and they developed a tool to better plan gate entry. And so we've worked and are working with ports to understand the bigger challenges on their end and how we can leverage either digital platforms or technology to kind of work on those programs. So there is work across the country, and Transport Canada has either worked with to develop or supported the ports through investment funding or working to convene kind of the stakeholders.
Excellent, thank you. Okay, I've got some other questions. I worked at Transport Canada for about 3 years. I know that the handling of dangerous goods is usually something that requires additional processing and that sort of thing. How does that factor into what you did in terms of would that add more port dwell time, or is that been factored into any of the work you've done?
I can't speak too much to it, but I do know that we work closely with our transportation of dangerous good colleagues to share data where we can in terms of expanding the visibility of goods coming into Canada. So on the import container side, the CBSA data, I believe, has a flag that identifies dangerous goods, and this information is provided through that similar process to that group, as well as some of their inspectors, to better flag dangerous goods coming in. So it's kind of an advance warning on identifying containers. So whether additional inspections are required, they're able to do that ahead of time.
Okay. You had a slide where visuals where you're passing data from CBSA to TC to the Port Authority and so on. Are you making use of international standards for data exchange there, or what type of models? Were they custom models that were built for that, or are you looking to move towards like a NEAM standard or something like that?
I can't speak too much on the standards. I didn't work as closely with the models, but I know that they pulled it from, there's an EDI, I think an EDI standard that CBSA uses, and so we leverage that standard to pull the data into our database. The data that's transferred to the ports themselves is pretty, it's quite not simple, but the elements are very simplified, and so that there's not a lot of information that is being transported. You're often seeing, vessel name and so on. But I know that the standardizing data exchange between stakeholders is definitely a key. It's a very important component for transport moving forward, and the stakeholders. I think we're just kind of at the precipice of how much data is being kind of digested or collected and then transformed between stakeholders. And so a big thing moving forward is ensuring that there are standards, and that if you're working with Port of Vancouver and providing them with information, the same kind of standards should be applied to the Port of Vancouver or Halifax or the Port of Montreal. So ensure that data can be shared, and then also between, say, the railways in the port and so on, so that there's not multiple types of data for the same, or multiple types of standards for the same data there.
Or even maybe the same that are being used in the other ports of LA and New York and so on too.
Yeah.
That'd be nice, international standards. Okay, so you talked a lot about how sometimes you're going to be relying on historical data to do planning for 6 to 12 months in advance for the Gateway Cargo Plan initiative. Given that we've had COVID for the last couple of years and more, do you think that will have an impact in terms of how you look at the data previous to COVID versus what's happening?
Well, definitely is. We're definitely having challenges understanding what's going to happen 1 to 2 months from now. And so when it comes to kind of working on, especially on the container side, I think we're still kind of very much we're very much still in the surge and the impacts on the container supply chain that started by COVID and has been impacted by various different issues. And I think we're going to need to take time to understand how to better analyze the data moving forward, because we can't always compare year over year anymore, because each year is really not similar to the previous. And forecasting, we have to kind of understand, do we use the past 2 or 3 years to forecast the future demand, or looking at infrastructure planning? Is the demand, or the number of containers flowing through the port today, really get a representative of what's going to see in 5 to 10 years? So is this something that we're seeing that's going to continue like this kind of surge, or is it going to kind of move back to the pre-2019 or pre-2020 kind of level? So I think those are questions that we're working on every day now, and we kind of see changes on a monthly or quarterly basis.
I can imagine. So
yeah, I think they keep saying that. I feel like every year they say that next year is going to be the year that the supply chains not solve themselves, but kind of this disruptions end. And it seems like every year they've been saying that now for 2 to 3 years.
Yeah, exactly. Who knows what the future will hold, but it sure will be interesting. Well, thanks very much, Matthew, for your presentation. It was very good, and it was great, and I really appreciate you presenting today, and really hope that you had a good time.
Well, thank you so much. Yeah, thanks. That was really great to present our work, and really excited to see where the work with the Port of Vancouver moves forward, and as well as beyond the Port of Vancouver, all the work we're doing with all stakeholders across Canada.
Excellent. So we should have you back, I guess, to report back as to how things happen in the future.
Yes.
Thanks again. I'm just going to sort of close out for the rest of the day. I appreciate the presentation. Thank you.
Thank you.
And so I just want to sort of say thanks to our presentation presenter, Matthew, as well as everyone else who presented today across 3 streams this afternoon, and as well as the earlier plenary sessions. Today's the first day, so we're just closing out for today. We'll be back tomorrow morning with more plenary sessions, followed by as well 3 streams in the afternoon, as well as in the after that. So there's lots more great presentations to come as well. So just thanks to everyone. Okay, have a great day. Cheers.